So when I use the term Regen Nut, I don't mean it in a negative connotation. I'm just trying to describe the intensity that some of these guys have in designing these receivers. I mean, when you find yourself trying to use transistors in funny ways or deliberately using the wrong grid of tubes, trying to make an NE555 into a regen, that's bringing you closer and closer to what we would refer to as a regen nut. A regen nut case is going to study every possible topology, circuit, everything that's ever been written, published, back of the napkin and envelope type circuits. He's going to try everything and trust no one. He's going to absolutely critique every part of the regen religion. Okay, I'm just picking on the guys a little bit. You know, some of these sites have absolutely gorgeous sets on them, and the quality of the videos and the production and editing is spectacular. You know, take Chappie Happy for instance. I mean, it's just so soothing and comforting to watch one of his videos because it's so smooth. I do have a picture of him that I'm going to share. I know he's quite shy, but I am taking precautions so that he's not readily identifiable, but I do have a picture. Here we go. And when you find yourself winding coils that are more complicated than a simple solenoid on a toilet paper roll, and you're using geometry and three-dimensional honeycomb Litz wire and special layups of wire to get these inductors. You've gone into this high level of regen nutville. I want to carefully go over some of the features of this 1929 style regen. First of all, it's got a vernier dial that's from the 1920s, and these are quite nice. They give you quite a nice tuning action if you use them with a small, stout variable capacitor. And we're only trying to tune a ham band, so we're not trying to tune a wide range of frequencies. So there's no need to have like 365 picofarad capacitor. The band set capacitor could be something of that size, but the band spread capacitor that we have the vernier dial on, it's a smaller cap. Also, it's a nice sturdy metal panel that's painted black. That could be crackle finish if you really want a nice set. And then we have the controls. We have the input coupling control, the regeneration control, which is really a throttle capacitor. And that's not a large capacitor. It's only about 150 picofarads. Then we have the band set capacitor here. This thing tunes so fine that it cannot tune the entire 80-meter band in one sweep. You basically have to tune for the single sideband and AM portion, and the entire CW portion is spread out from 0 to 100. So it gives you some really nice band spread. And finally, we have the audio amplifier potentiometer. This switch changes the bias on the detector from 24 volts for AM operation to around 56 volts for a single sideband and CW. And then we just have the phone jack. Now on the bottom I've got some aluminum foil. The aluminum foil is folded up into the top. It's folded into the front panel so that we have a DC connection. That provides a ground plane underneath the wiring. So there's a sneaky trick, using some aluminum foil to get a ground plane under the receiver. Let's look at some of the features of the back. Notice how the wires going to the audio pot are twisted pairs. There's also twisted pairs on the filament because we're using alternating current AC to light up these tubes. Some of the tubes here used in this Regen are directly heated filament type tubes where there is no cathode. And others are called super triodes. The super triodes actually have a cathode. This is an example. This is a type 76 triode. It actually has 5 leads instead of 4. There's 5 prongs on the bottom of that tube, the 5th prong being the cathode. The type 27 was one of the first popular tubes to have a cathode. So I'll have a variety of tubes at the end that date from, the early 20s up through the early 30s. And all of them are good candidates for a regenerative receiver. You'll also notice we have a hum pot here. This is across the twisted pair that goes to the filaments. When you're using directly heated triodes, the use of twisted pair along with a hum balance pot allows you to use AC on the tubes without getting AC into the headphones and disturbing the good sound you get out of these regens. It's also useful for the cathode type tubes, and of course if you're running DC you don't have to be as fancy with your wiring. I mentioned there's a bias battery here. The bias battery is really made of 2 penlight cells, so that's 3 volts of bias. This is the interstage transformer. It's a 1 to 3 step-up transformer. Now technically the output could go directly to the headphones without an output transformer, but I knew I wanted to use this set with low impedance headphones like 600 or 1000 ohms. So I have it's about a 7K to 600 ohm output transformer here. On the 80 meter band, the antenna and ground terminal is connected to the lift link assembly. Notice that it's only a couple of turns. Some people actually use a single turn coil on 80 meters if they have a really good antenna like a high dipole. You usually have so much signal that the Regen overloads. Once you get down to the broadcast band, you can talk about using 5 or 10 turns on an assembly like this. But you could imagine getting 30 or 40 dB of attenuation out of an assembly like this. Being an Armstrong type Regen, we have the secondary coil here with the ground end on top. This is all ground. Hot end, and then the tickler down below. A little bit unusual, but this gives you good performance on 80 meters. Here's the throttle capacitor. Hope you can see that. And a few old-fashioned resistors and capacitors that make up the Regen. So we have the high voltage connection and the AC for the filament on these terminals. It's kind of a homebrew assembly. I found some old pieces of phenolic and some old-fashioned battery terminals and made those up. They don't look too bad. Same with these transformers. These are World War II transformers, but painted black, they look pretty good as a period substitute. So that's the classic goat shield on the detector. Grounded to the tube socket. So everything that can be grounded is grounded, and we're using heavy-duty number 14 tinned wire on all of the main connections, ground and RF connections. So here's the band set capacitor and the band spread capacitor. And there's actually a couple of padding capacitors in there to spread out the band just perfectly to cover the whole CW band with one sweep. And then you move this a little bit and you can cover the whole phone band with one sweep. You can also see that we have a 6 millihenry choke along with a 10 meg grid leak resistor, which is a period part from the 20s. So let's look at some of these wonderful 1920s vacuum tubes. Of course, the Type 27 is the one I would suggest to use in a circuit like this. 27 comes in both the globe and the and the non-globe type styles. This is actually I think this is a 56. No, it's a 27. So this is a little more modern 27 in the ST package. The 227 would be the older tube. So here's a Globe 56, another excellent triode to use in the Regen. Type 76. I think that's what I actually have in this. Oh, I forgot to mention the Type 26, the 226 or the 26. Another triode that would be a good candidate. For a little more modern tubes, maybe mid-30s, late 30s, the 1H4, this would be a good candidate if you were doing like a battery type Regen, a pair of 1H4s. So just a small assortment of tubes that would be appropriate in the 1920s Regen. Here's a list of some popular tubes that were used during the 1920s and well beyond. Starting with the 01A series, and believe me, there's variations galore on all of these tubes. And when you bring the European tubes in, it becomes a gigantic. You would have hundreds of tubes listed, but I've taken the basic tubes and put them in this small chart. These are a few of the popular tubes. The 01A, of course, is a low gain, low mu triode, and it's general purpose. They used it for RF and AF stages, oscillators, you name it. The 01A is a great little tube for a Regen and totally appropriate for the 80 meter band. Then we get to the Type 26. It's still directly heated, but made in great quantities, less expensive than the 01A, especially nowadays. The UX99 is the first attempt at battery triodes. These are triodes that have filaments that allow you to use battery, and portable type radios become possible with the UX99 and that family. The Type 27 is the first of the super triodes with a little bit higher gain. We end up with 820 micromos and a gain of 9. Notice these are low mu triodes, but they work just fine in Regens. I've found that triodes that have lower gain provide smoother regeneration and better control, especially when you're doing AM, than the higher gain modern triodes. The Type 37 is just about identical to the 27, except for the 6.3 volt filament, which is basically what modern tubes used for many years. The Type 30 was extremely popular, again in the portable radio, 2 volts with a 60 milliamp filament rating, made it a very efficient 1-tube Regen or 2-tube Regen. During the 20s, this would give you the ability to have a battery radio with excellent performance. You start to get into some of the higher performance triodes by the early 30s. And the Type 56 and 76 represent super triodes that have higher gain. I'm using 76s in this receiver. The 76 is an excellent tube. It's similar to the 6BF6 that Morgan uses in his book, and it's very well behaved in a regenerative. The The 1H4 was a tube that Morgan actually used in his first edition of the boys' first book of radio and electronics. It's also a battery tube, so operating on 2 volts with a 60 milliamp filament. Okay, time to look at the schematic. As you can see, this is a conventional Armstrong regenerative receiver with a band set and a band spread capacitor. There's some coil data there. I wound on a ceramic form, but you can certainly use a PVC or a cardboard or phenolic form. And anytime you change forms, change the wire diameter, or change the spacing between the turns, or any of these variables will of course influence the number of turns you need on the coil to hit the band. So you almost always are going to need some small pattern capacitors to put you right in the band where you expect to be. You're never going to hit it perfectly. This is showing the indirectly heated type of tube, which the 27, 76, 56 are all cathode type tubes. And you can see the twisted pairs used on the filaments, the throttle capacitor with the 2.5 millihenry choke. We have a voltage divider made up of R2, R3, and R4. And this is that system I was telling you that allows you to adjust the voltage on the detector for 24 volts for AM and 56 volts for CW and single sideband. T1 is a 1 to 3 transformer, high impedance, so you're going to have a couple thousand ohms on the primary and probably 6,000 to 10,000 ohms on the secondary. I've got a capacitor that peaks up the CW. It's a 0.002 that works with that coil, and it roughly resonates and gives you a little bit of peaking action. The bias is a 3-volt battery, and then we have the transformer in the output that feeds the headphones. You'll see the hum pot just is across the 6.3 volt AC to ground, and you just turn that for the minimum hum you hear in the headphones. I'm running this on 150 volts. You could certainly run on anything from probably 50 volts to 150 volts. You just have to adjust the voltage divider accordingly. So let's have a little shootout between what many consider to be the king of receivers from the mid-1950s against the 2-tube Regen 1929 style. Now the R390A has 23 tubes, triple conversion on 80 meters, 10 tuned circuits between the antenna and the detector, and it includes mechanical filters. We'll be using the 1 kilohertz mechanical filter for CW. It also includes a 100 hertz crystal filter, which we will not be using, an audio active filter, which we will not be using, and reworked audio hi-fi. I've got a 6AQ5 in the output with a hi-fi transformer, as opposed to the original 6AK5 into a 600 ohm output. We're going to be using that against the R29 1929 style Regen. It's got 2 super triode valves, 1 tuned circuit, no additional amplification. We're going from a 600 ohm to 8 ohm transformer right into a speaker. So there's 2 transformers on the output. We've got the original 600 ohm transformer feeding a 600 to 8 ohm transformer into the speaker. Sounds like a fair fight. Let's see how they do with normal CW. So here's the Regen on CW. the R390, and the Regen. R390, and the Regen. Okay, we've got code practice with W1AW, and coming in nicely on the R390, very strong signal. And to the Regen, actually too strong. I have to back off on the coupling. The R390, so I turned the Regen up a little bit more, putting a little more voltage on the Regen so it goes into regeneration more. This stabilized the signal somewhat. Now we can bring the coupling up. The R390A and the Regen. The tuning rate on CW is pretty nice on the Regen. Band's spread out nicely. Some pretty weak CW. It's a pretty weak signal. This is the R390 in the 2 kilohertz position, single sideband, upper sideband weather.
Yo entiendo la propagación, pues no está buena y yo lo que transmito es con 100 vatios. Así que buenas noches y será entonces hasta mañana. Ok, pues nos dejo por ahí, tranquilo, por ahí. Sí, yo me quedo fuera. Alfa, Bravo, Sierra, me quedo fuera. Chao. 7-3.
I'm going to talk to 160, because I know a lot of guys here don't have it.
Let's try some stronger single sideband stations.
Organic, go off and say grown and shit. Kill ourselves as. Yeah, but it's organic shit, Larry.
This is a pretty strong single sideband station.
Gotta actually quit sitting here and that's the computer. Okay. I hope everybody has a good day, have a good weekend, and I gotta go to a wedding.
The sideband, especially in a roundtable net, tends to easily get overloaded as you go from station to station. It's difficult to make the regen happy on every station. On any one, you can usually do a good job, but when it's a round table and you have a weak station and a very strong station, the regen gets overloaded quite easily.
Happened, where it went. Well, a little irritating there. Like I say, Microsoft Edge, use the file fine, but if you want to print like one page or something, you can't. I couldn't figure out how to do it, and I just wanted to
The Regen
print one page. Adobe is
R390,
to do that.
8 kilohertz position.
Okay, good luck with Adobe. Gotta get into pickleball. The women are. That's all. I meet a lot of women. Not that I'm, like I'm dating any of them, but I've come across a few that are dateable. There's one I like. I should probably pursue it. I really should pursue it harder because I really like her a lot. And we did go out on a couple dates. I guess you'd call them dates.
Welcome to the 75-meter dating club.
Whether it was a date or not, I don't know.
So that was a nice little tour of the 1920 style Regen. I did want to show you what the power supply looks like. There's not much to it. Just a small transformer with a 6.3 volt, really just a 1 amp winding on the transformer. And then 120 volt winding that's rectified and uses a voltage divider to bring it down to the 150 volts that we need on the radio. So it's a very simple power supply, not very big. I'll set up the schematic so you guys can see that. What we found is that the Regen's very sensitive, and with just 2 valves, 2 tubes, it's able to hear most of the things that the R390 can hear, at least using most of its resources. Once you put the R390 into the crystal CW position and really cinch down the RF gain control, I think you would find it can hear things that the Regen cannot hear. But those are going to be some pretty rare signals. The Regen also has a very pleasing signal to noise ratio, meaning you don't hear a lot of background hiss compared to the R390A. The R390A has got so many tubes that the background hiss is always there. With the Regen, it tends to hang on to the signal much like a phase lock system. In fact, on many signals, AM included, the Regen actually does phase lock to the signal. So it can give a very pleasing output compared to many super heterodynes. With only 2 tubes, we didn't have a lot of gain, so I had to use a pretty efficient speaker for you guys to hear anything at all. And there was no additional amplification. We basically were just working with the 2 valves, that's it. Detector, amplifier, and this is made for headphones. So the idea that we ran it through another transformer and drove a speaker and were able to get anything out of it, I was very pleased with that. So some people might have thought this was a very unfair competition between the R390A and the Regen. Remember, the R390A was designed for one job. It was designed to be put on one frequency and left there forever. It was not a scanning type receiver where you're looking over the whole band for signals and then concentrating on them. So the tuning on the R390A is not pleasant compared to a regular receiver. It tunes very fast, especially on CW, and that can be problematic when you're looking for signals. So a wider receiver with a pan adapter probably was the way that you search for signals. And then once found, you put the R390 on a frequency like a teletype signal or a CW signal, and you left it there. Also, it was pretty apparent that the R390 is not the best single sideband receiver in the world. It was designed in a world of mostly AM and CW, not single sideband. Some of you mentioned that you're interested in having me fire up this regenerative broadcast band receiver here, and I think that's going to take another full video to do that. Just to get the power supply straightened out, get the thing working. It's never been fired up. I've never actually operated this receiver. It's going to make a whole video in itself. So working with regens is a lot of fun. The 1 and 2 tube hobby radios, getting something out of the headphones on the AM band, that's a lot of fun. But once you cross over that threshold into the high performance regen, it's a whole new world. We've seen what a higher performance regen can do using 1929 type technology. Imagine what a modern regen from the 1950s perhaps with a Hartley type system could do. So I hope this opens your eyes to a whole new facet of regenerative receivers. Regenerative receivers that can compete with some of the best receivers in the world.